Good morning everybody. I am Dhirendra from NI Private Limited, Pune. A warm welcome to all of you from NI2 Designs, Pune. We are working on various domains like VLSI, embedded system, microelectronics, your antenna designing and EMI, EMC, and we have our own design cell in Pune. Our headquarters is in Pune, and we have a lot of sub offices in all over India and even in foreign also like Bangkok, Thailand, Malaysia and in Singapore. And now we have started our office in USA. Today I am here to give presentation over this CMOS VLSI technology. So, we will start this. This will be the agenda for today's seminar, and like nanometer era, history of IC design and technology scaling roadmap, design trends, recent developments and programmable logic device. I will take it little bit tomorrow in detail, introduction to ASIC, design of CMOS ICs and so on. Let us start. As you know, in VLSI nowadays what is happening, complexity is increasing day by day, and like your gate count is even increasing day by day. So, we are expecting like very high speed and like low power consumption, and like we are adding more and more feature. So, it is little bit challenging for us. We have a lot of EDA software also, but even though it require very like too much concentration for any kind of design. So, let us talk about the CMOS, why this technology is popular right now. You have any idea why we are considering this CMOS technology? Right now we are in nanometer era, we are like currently working in 45 nanometer technology. So, what do you think that the reason behind this CMOS?
To high packing density as well as low power consumption.
Yeah. So, these are the some reasons, like low power scalability is possible for this one, and a very high level of integration, and then high performance fully restored logic, and the best thing is that rise and fall time transition is like almost equal. We can go for that also. This is the brief history on integrated circuit. In 1940s we have just in starting stage, and 1950s we have invent the integrated circuit, and 1960s the basic MOS, CMOS, BiCMOS, like this kind of things, advanced technology we have produced. 1970 we have like designed EEPROM, DSP, DRAM, microprocessor. In this way, right now we are in this era 35 to 45 nanometer technology. We have already developed like chip up to like 65 nanometer technology. Currently, we are in the stage of this 45 nanometer technology. So, this is the roadmap, you can check out. Right now, we are here 45 nanometer technology. So, everything is improving, like your 30% reduction in transition switch power, 20% improvement is in switching speed, and like this density is even increasing day by day. This is the some electrical parameters for your 45 nanometer technology, like ion time for P type, N type, I of type, this much. We have to, like you can check out this interconnect layer permittivity. Nowadays the stent technology is very popular. This is because like what do you means understand by this 45 nanometer technology? What is this actually? We are saying that we are working in 45 nanometer technology. What is this exactly? Gate length, yeah. Exact the basic MOS, that gate channel length will be that much of length 45. So, there is a lot of like challenges, like we have to maintain proper distance between the atoms, so that we can control the flow of the current. So, this stent technology is basically will put this nitride capping over this gate, drain and source. after putting this, what will happen? It will produce some mechanical strain on this, okay, and we can properly control this channel length. So, this technology is in right now we are using for 45 nanometer technology. See this is a bacteria size 2000 nanometer, and we are talking about this 45 nanometer. So, you can imagine that how small 45 nanometer, and we have research work for up to 9 nanometer technology, but it is too difficult to achieve that thing right now. We are trying, and this is the roadmap for your IO and chip core voltage. As the technology is advancing, what is happening, this input supply voltage is decreasing, because we are trying to reduce the power. So, definitely this input supply voltage should be reduced. Right now you can check out this one 1.5 and this one 2.5. This is the design trend. Initially we rely on this IP code. You are familiar with IP codes? These are like blackboards. We call this intellectual property code. Suppose example, there are ready-made masala in market. We have उसमें क्या होता है कि आपको उनके content पता होते हैं, but how they prepare that you don't know. These IP code are like that. These are in coding using HDL language like VHDL Verilog, but that source code will be not available to user. You can use that is a black box, according to your requirement you just purchase that IP code and आपके डिज़ाइन जो है उसमें यूज़ कीजिए उसको. सो इनिशियल स्टेज में क्या होता था, वी गो फॉर दिस IP डिज़ाइन और बाय हैंड ऑन प्रैक्टिस, क्योंकि इतनी कॉम्प्लेक्सिटी थी नहीं एट दैट टाइम, एंड सो नो नीड ऑफ इवन दैट मच ऑफ एडवांस टूल इज़ नॉट देयर. So, but right now we are in nanometer era, we need some very sophisticated tool for this. So that that TTM, time to market, can be reduced. This is the things, layout design. We will talk about this one in deep after this presentation. These are the design trend. These are models. These are the basic model. You are familiar with BSIM 4 model? Actually, these are you can say it define the parameter. BSIM 4 means it is very advanced model, it will define up to 300 parameters. We will discuss that thing in software when we will go for that, what is this model and how we can utilize this model for our perfect simulation. These are the recent ICs Intel Pentium 4, that is for 90 nanometer technology, and the operating frequency is 3.73 gigahertz. Okay, up to 2010 we are expecting more than 5 gigahertz. 169 million transistor, you can imagine how compact is this chip, and these are other chips AMD and Intel Intium. This is the roadmap for IC processor in 4004 in 1971. We have just only 2300 transistor, and now we have developed this one Intium 2 with 9 MB cache memory. So, you can look out the number of increase in transistor. So, definitely the challenges is big, and we need some definitely some sophisticated tools also, well trained designer also, so that we can get our chip according to customer requirement, according to the specification which is required in market. This is the for Intel 4004 processor. इसमें आपको कुछ ज़्यादा नज़र नहीं आएगा, just the interconnects, but it's okay for this. At least you can check out the interconnects and some blocks, but for this one this is Pentium 4 processor. Okay. Here you can check out only like few clock trees and like few registers and like not more than that. Okay. Why these colors are there for this one? Like different colors are there in this. This is the microscopic view for this processor. This is due to interference. Actually, we are taking the microscopic view, and these color are due to interference. So, nothing more than that, but you can check out the complexity. It is like complex, and you can't like guess where the components. Now, the question arises that in 1971 we have developed that 4004, and now we are in this Pentium processor, that is a very fast processor, and operating frequency is too high, and like that gate per count is even is comparable high nahi. So, what do you think the biggest changeover in this itne development mein within like 3 decades we have developed this kind of chip. So, what is the biggest changeover within these 3 decades? Why now we are capable to develop that kind of chip like?
Better fabrication technology.
Okay. And but what is the main factor like पहले हम लोग like that complexity is not so high, and now the complexity increases and requirement is too high. So, even though we are we can develop that chip in like proper time में हम develop कर सकते हैं. Why? The reason for that is just simple, that is EDA tool. Okay. That जो पहले manually calculation होता था, everything right now we don't need. We have to concentrate only on design and some like जो parameter arise होते हैं latest technology में, we have to see that only. So, we have a lot of powerful EDA tools for that, like I will tell this one. This is the ASIC design flow actually. You can divide this VLSI into 3 parts, like front end, back end, and your foundry. Okay. In front end, what the designer do, according to the specification of the customer, he will go for this design entry. Okay. And then there are process like synthesis, simulation. You are familiar with this kind of process, synthesis, simulation. Synthesis like design entry, you all are familiar with VHDL coding. Okay. So, after this VHDL coding, like simple example I will take like full adder, एक full adder का code लिखा according to the specification, like time उसमें आपका area constant होगा, there will be speed constant, and according to that, after that you will synthesize that you will write in some high level of abstraction language, like behavioral level or data flow level. I will explain that in deep when we will take that front end part. So, after like writing the HDL code, we will go for synthesis. This is the process to convert your high level that level language into like low level module, gate level. Like आपने behavioral level में लिखा है, but that is not the real part. You have to convert that into netlist. So, this synthesis process will utilize this technology library of this software, whatever, like Ultra, Xilinx, whatever, and it will then convert that into gate level netlist. After that, you need to like optimize that and properly route and place, that is the later one part. After that, we will go for static timing analysis. There are some timing libraries according like that is practically based on the foundry, like whatever we have developed up to now will based on that timing parameters, we will go for static timing analysis. Okay. Then there are some simulation. Simulation means like you have to verify like functionally or like timing wise. So, first one that is simple one, functional verification. After that, there are 2 type of simulation, pre layout and post layout. Pre-layout means we will just whatever the code we have written according to the timing and technology library, we will just find out that kind of like delays and but now we will not consider the routing path, because we haven't gone through that like proper place and routing and like optimization process. For that we need proper optimization process. After that we will go for this post layout simulation, that will give the detailed information about my chip, means it will work or not, like at that operating frequency or not. So, these are there are test benches we have to write separately to generate like clock signal, like different kind of signal to verify my this design. After these kind of synthesis, simulation, design entry, we will go for module partitioning. What is this? This is like suppose you have like two big circuit. So, you have to divide that into like you have to partition that. So, that simplicity can be done possible means, and you can go for this floor planning, this one according to area constant, like आपके पास chip area whatever the specification, you will go for floor planning. This is like manually you can say, or based on some algorithm, optimized algorithm, you will like similar to that PCB principle. PCB में आप क्या करते हो, you just select the component and proper PCB layout बनाते हो, then you just plan that where we have to put that component. So, similarly in chip designing we go for that floor planning, where I have to put this block, where I have to put label shifter, where I have to put analog block, where I have to put other blocks. So, this is like proper management of that chip area. After that we will go for layout compilation. This is like basically you have to compile your layout, that mask you have to create mask for your chip, and then place and routing. I will explain this in deep using the software, because that will be the best part to explain with the software. And after that we will go for cross sectional analysis. These are some analysis, like we have to like parasitic extraction analysis, and there are few more analysis. I think you all are familiar with PSpice. So, similarly we have some like analysis in this backend tool also. We have to go through that. After that like verifying everything, like my design, my like layout, everything, I will go for foundry, because this process, whole process is like too costly, coming from this to this. My single first chip will be more than like that cost will be more than $1 million. After that bulk production it will be cheap, but initial that block जो आपका chip होगा, that will be very costly. So, no one can take that much of risk. So, properly and even there is a pressure like time to market, there is too much competition, और हमें उस time period में अपना chip निकालना है. So, there are lot of different engineers working on this whole process, and finally जो like project का जो time decide होता है, up to now, up to till that we have to verify that properly. So, you can say that only 30% time is needed for like this kind of designing, synthesis, simulation, but most of the part 70% that covered by this backend tool, and that is practically actually. Front end you have just written the code and verify using the software, that is based on the software algorithm. So, you can't say exactly practically that it is definitely I can get my chip. So, you have to use this backend tool, you need to expertise on backend for that. After that this is the flow for this foundry, this is not for the designer. These are like chemical engineer or whatever mechanical engineer in foundry. Okay, let us come to the point again, the ASIC. I think you all are familiar with this application specific integrated circuit. Like we are designing any kind of chip like for specific purpose, like these are the some examples, like DSP function in hardware, like MPEG decoder and chipset in PC and baseband, but these are not like ASIC, because these are in general chip. So, according to the requirement means the designer can go for ASIC or whatever other general general purpose chip. These are the reason why we prefer ASIC, like technology driven and market driven. These are the two factors which like compel us to go for ASIC designing. This is the costly, definitely the costly process compared to like even FPGA CPLD, but in bulk it will be definitely cheap. These are two type of ASIC chip, like programmable and non programmable. I think you all are familiar with FPGA CPLD. These have the flexibility to reprogram this one, and like non programmable ASIC that will be like standard cell, based on standard cell or like full custom design. So, first we will go for this non programmable ASIC, but before that I want to discuss some the important thing about any kind of any software, front end software, that is ASIC cell library. Any tool can be powerful after like उसका अगर cell library powerful नहीं है, then we can't go for like proper simulation synthesis. जो भी उसके process होंगे, we can't perfectly rely on that. So, the cell library is the most important thing, that is based on like technology or like whatever we have achieved up to now. These are the various like modeling, different kind of modeling, and like physical layout, behavioral modeling. I will discuss this thing on later one. Okay, now come to the this front end part, this non programmable ASIC. This is like full custom ASIC. Full custom means each and every part we are designing by like we are concentrating on each and every part. So, from starting point of view it will take definitely a huge time, क्योंकि आप एक एक part को अपने like you have to properly simulate that, and you have to like properly analyze that. So, it will take a lot time for full custom designing, and but the thing good thing about this full custom design is like definitely you will have like very high speed and like very high performance compared to that that we call semi custom design. In semi custom design like that is based on like आपके पास पहले से there are some blocks, you have ready made blocks, you are just taking that from market and just you plan proper management आपने बनाया है, then according to the area constraint you have managed that, and उसमें हो सकता है there are few blocks like which is needed to be designed, but other are like ready made. So, it will definitely take time, less time compared to that full custom, because वहाँ आप initially से जा रहे हैं, and for this that is not the thing, but you can't exactly say that it will be like that much powerful as full custom or not. But the thing is good for the like companies that TTM is less, time to market. You can develop any chip in few months, like 2 months, but for like full custom design you need like at least one year maybe, because complexity is too high nowadays. And these are the programmable ASICs. Those are non programmable, these are programmable. These are popular because like you can reprogram them, and definitely आप जो भी bugs हैं you can remove that, and like within few seconds remove किया, then again reprogram that, you can verify that. So, these technology are like very popular nowadays, but compared to ASIC, that non programmable, we do not prefer this one, because it is okay for like for educational level or for verification we use this FPGA CPLDs, but like for like bulk production, suppose you want like that processor based on this ASIC programmable ASIC technology, so you can't go for that, because the एक आपकी जो बेसिक FPGA की जो कॉस्ट होगी और 1000 जो होगी that will be same, but for ASIC में क्या होगा non programmable, if you आपके मार्केट में काफ़ी चिप्स आते हैं, definitely that cost will be reduced. Okay. So, these are the basic difference between full custom, semi custom. So, before any kind of designing the designer should have that kind of mind like what to prefer, what is like my requirement and what is the specification given by the customer. So, these are few comparison like architecture difference, you can check out this like everything, cell size, cell type, cell placement, interconnects, all are variable in full custom, that is according to the designer or like even the specification. But for others something is fixed, like something is programmable. So, few flexibility is there, but best thing is full custom. Okay. These are like comparison of area, performance and fabrication layers. You can see the presentation. The performance definitely performance will be high for this kind of full custom, and area will be compact, because definitely पहले से माइंड में होगा कि we have to like compact the area, और FPGA के लिए आपके लिए that will be very large, means most of the area is like waste of area. These are some ASIC application like aerospace subsystems and sensors, wireless communication system, medical instrumentation, telecommunication product, consumer electronics, CDs, digital synthesizer, mini disc, computer products, graphics cards, and PG technology. So, these makes the VLSI as a booming field, like the latest technology. So, we are going for advancement of this technology. Okay, this is the simple CMOS layout. You all are familiar with the layout, basic lambda design rules, little bit. Okay, you can see I have already explained that CMOS technology, like why it is popular. One more thing about that is that that drawback for NMOS and PMOS, weak 0, weak 1. I think you all are familiar. That is overcome by this complementary MOS technology. What we will do, this is a I will explain this thing by using the software, but this black screen is by default P type, and this layout is for P, and this is for N, this one, and this is the polysilicon, this red one, and this is the diffusion layer, green one for this N type, and this is for P type. So, these are like using the software I will create some mask for this PMOS and NMOS, and after that I will like connect this gate. This will be the common, like so, this is basic CMOS inverter, and this is the what I have done here. I have common this gate, this red one is like gate, and this is gate for this NMOS and PMOS. I have made common this one. I have taken output from this one, and this is metal 2 layer, metal 1 layer. Actually, I will explain this one later on, like why we are using different kind of metal layers, what is the purpose, and how to optimize this circuit. This is not the optimized circuit, and you can see this 3D view, like just ऐसा लगता है this is like building blocks. This is like your P type and N type, and this is by default P type substrate. This is based on actually lambda rules. Lambda means that is a parameters defined by the foundry, and like lambda like they have defined for this polysilicon that width should be at least 2 lambda, and like for this interconnect, for metal, for this like overlapping, for this like extension कितना होना चाहिए, at least that should be 3 lambda, and like this overlapping should be like 4 lambda, this kind of things. For metal interconnect, this 6 lambda. So, these are based on lambda rules. These are just like mask for your chip. Okay. These are the design rules like based on lambda, and for everything like via salicide option, lateral drain, antenna ratio, supply rules, ESD rules. So, we have to follow these rules. These rules are given by like a specific foundry, and according to that we have to simulate, like we have to simulate our layout, proper simulation of our layout. These are some issues we have to always keep in mind, like antenna ratios, and we have to maintain a proper length so that this effect can be reduced. And like supply design rules, these are some rules related to designs supply, and like you have to create some slot. If you are taking some like width of that that supply, this interconnect is more, you have to put some slot here. So, this is because so that power dissipation ज़्यादा ना हो, means easily the signal cross talk effect, there are some like few effect वो ना हो cross talk effect, like I will explain that one also. These are like rules regarding to supply regarding these interconnects. We should try to put more and more interconnect. This is because suppose like maybe possibility if some current is driving like little bit higher, there is possibility that whole chip can be damaged. So, even like we will put more interconnect, so the possibility there will be not possibility of like breaking, like इतने सारे interconnects होंगे तो definitely जो breaking possibility होगी that will be reduced. This is the ESD rule, we have to keep this circuitry at the pad position, like suppose if there is a low voltage, so that will be sink, and if that little bit high voltage, that will be like through this that will be source. So, my chip will be like shape here there is my chip, and here this is the supply pad, and so I have to maintain some like some range of that voltage. So, these are related to that ESD, and these are some state ratio, that is like if you want to drive more load, so you have to maintain this chain. This is like little bit इसको higher करते जाइए, the size will be little in this size will be more than this one, then this size will be the more than this one. So, it will like you can drive like high load. So, these are the some issue you have to maintain, like state ratio, ESD rules, supply design rules, supply design rule for this interconnects, and antenna ratio. This one is cross talk, like during routing this problem arises actually. There can be interference between the two signal, like this one is metal 1 layer, this one is metal 2. So, you have to maintain proper distance, and like there are a lot of parameters which will affect this one the signals. So, you have to keep that thing in your mind, so that cross talk effect can be reduced. And now, we will switch to this power consumption, like why we are worrying about power, what is the reason, like why we are trying to reduce the supply voltage. Power dissipation, but वो पहले भी था. Now, why we are reducing that, जैसे जैसे टेक्नोलॉजी एडवांस हो रही है, why we are reducing that. एक्चुअली जो रिक्वायरमेंट है कस्टमर, लाइक फॉर दिस लैपटॉप हम चाहते हैं कि ज़्यादा से ज़्यादा इसकी बैटरी चले 3 घंटे 4 घंटे, कम से कम पावर कंज्यूम हो. डेफिनेटली जैसे जैसे एडवांसमेंट आ रहा है, we are trying to reduce the power consumption. So, that and another thing is that heat problem, that is like the compact chip, and like so density is too high. So, definitely there is chance of damage of the chip. So, for that we are like we have separate design like engineers, we have to like concentrate on that thing only, like how to reduce that power consumption. These are the two factor three factors actually, where actually this power goes for dynamic power consumption, that is like essential transition जो भी होता है, at that time there will be the power consumption whenever there will be transition, and like glitches, and like this short circuit, and finally the leakage. There will be definitely some leakage. We can't like, we can reduce that, but up to some level. So these are the three things where the power will be consumed. So we have to concentrate on these three factors. Now for next, here I have this input 1. At this time this will be off, this NMOS will be on, this will discharge, and finally I will get this 0 1 0 inverted output. But practically this is not possible, this like this sharp edge is not possible. Practically we have this kind of like rise time fall time. So what will happen for this one, like this one and this one, यहाँ पर there is a possibility of metastability. You all are familiar with metastability? Metastability means you can't say that is 0 or 1. So at this stage these both will be on. So there will be this current will be sourced to the ground, and definitely there will be current spikes. So at that transition there will be the maximum power consumption. So we have to reduce that one, and for CMOS technology the best thing is that we can like maintain this rise time fall time like just equal. So this will be helpful for reducing the power consumption. This is the reason for glitches, like if two signal are I am not getting exactly at the same time. So definitely there is chances of glitches. You all are familiar with glitches. So we have to overcome this also. This is the main factor which will like add to the power consumption, and this will be the total power consumed, F the operating frequency, and C CV square. So this is the basic actually. So you can check out this, most of the like power will be consumed by clock, and 20% will be by cache memory. So this is so we have to mainly concentrate on clock and like this cache memory. We have to get this proper operating frequency, so that we can reduce this power consumption. So these are few methods for saving power, like I think you are all are familiar with this sleep mode, snip mode. So like जो लैपटॉप में होते हैं हमारे, and like we reduce the capacitance and like node capacitance, and like decrease the fan out. अगर आपको ज़्यादा fan out चाहिए तो you just duplicate the logic, and like place buffers. These are the method, or like stop clocking, like idle for idle circuit. So these are the method to save the power, but there may be others one as the technology advance. So the main thing is timing issue, how to like find out the exact operating frequency, so that I can reduce the power consumption. These are two methods to verify the timing requirement of RTL circuit. First one is static timing analysis and dynamic timing analysis. We have to analyze both one, and like here we will go for maximum operating frequency. I will tell you how to calculate this operating frequency. Actually this is the like two vast topic to cover. Actually for this a lot of expertization is needed, because this is the main issue for any kind of chip designing. So separate design engineers are there for this purpose. So this one you can check out this. For any like chip there will be the delay from flip flop to rest delay, that we call rest to rest. We have to take concern about this one, because this is the main factor. I give the reason. See this PPT. This is D1 flip flop, D2 there are some combinatorial circuit, and you all are familiar with setup time, hold time. So, we have to maintain that one setup time and hold time, so that we can overcome this meta stability state. See this, at this when the data will be stable here D1, after TSU setup time, my data will be out here Q, that will be like TCQ, clock to Q delay. So, my I will add that one, T minimum will be T clock plus, then next you can check out that now my data is stable at output of Q1. After some delay this TPD, I will get this at this D2 point, and for this the setup time will be this and hold time will be TH. So, we have to consider this setup time for this T minimum. At this my data will be at output, will be capture. So, my T minimum will be TCQ, this one setup time, this one TCQ from clock to Q, after that this delay, and after that this one. So, this will decide the operating frequency. So, we have to take like main concern for this kind of like rest to rest delay to calculate the operating frequency. One thing we always prefer not to gate the clock, because it will create always the problem, because unwanted problem you can see. These are some technique to improve the speed, you can read out this, like keep the logic gate depth shallow between the flip flop, avoid circuit design that have highly loaded gates in the critical path, and like duplicate logic to reduce fan out, and this is the best thing, pipeline the logic, we just prefer this one, and after like proper clock distribution, that is the main fact actually, timing issue. These are the latest trend we are adopting, like system on chip, and like system on chip means like all like your RISC, DSP, like DMA controller, SRAM, we are creating that in a single chip. So, now the main concern of the designer is hardware software like co-design. We have to maintain like proper interfacing between hardware and software, like hardware में अलग चल रहा है, then software में अलग चल रहा है. So, definitely the difficulty arise after like जब हम उस स्टेज में पहुँच जाते हैं, फाइनली हार्डवेयर डेवलप होता है एंड योर सॉफ्टवेयर. सो एट दैट टाइम देयर इज प्रॉब्लम लाइक इन इंटरफेसिंग. So, right now we are preferring one language, that is system C, that is like equally preferred for like software designing and hardware purpose. So, this is the like main reason we are going for this system C, leaving this VHDL and like very low, not leaving, but we are still utilizing that, but system C is like popularizing today. This is the latest technology, but right now that is not in market because of like few reasons, that we call system on insulator. I think up to 2010 we will be definitely expertise on this technology. Actually, this technology is like to reduce the parasitic capacitance. Here you have the like this one substrate, after that you will put some like dielectrics, over that you will put some pure like pure silicon layers. So, definitely that parasitic capacitance will be reduced for this technology. So, the thing about this is that this chip will be 50% like more faster than right now, and the best thing is that power consumption will be reduced up to 30%, but practically अभी तो possible नहीं है ये, we are trying best, but the उसके लिए reason भी है, because this is very costly up to now, जो अभी at present है उसके compare में 10%, like 10 time, not 10%, 10 time costlier. And another problem is that we do not have like perfect like what we call designer, जो ट्रेंड डिज़ाइनर चाहिए होते हैं, दैट इज़ नॉट अवेलेबल इन मार्केट. So the growth is not there for this soil technology, but still our tool like microwind, it have support for this soil technology. Someone is interested for this one, he can go for this one like software, for software purpose. Now EDA tool, why we are like so much concentrating on this EDA tools? This is the reason. You can read about this one. And this is the thing what EDA tool means help us, like manual layout जो होता था, that is we are doing with the help of EDA tools now. So that save much time, and after that like this one large design, suppose you have too much complexity, and for that it will be preferable, and NRE cost is reduced. This is non recurring engineering cost. This is like once we invest the money on like whatever the resources, that will not come back. So this is the headache for the company. Suppose my chip will not working, so I can't get this NRE cost. So we have to see for reusability, and proper verification is needed, that is only possible by EDA tools. There are like very dedicated software for like verification only. The thing about the EDA tool is that 80 to 90% means software आपको सब कुछ करके नहीं देगा. You have to like explore that one. 80 to 90% will be self assisted. Okay, that is based on cell library and algorithms. So but the main thing that will be decided by designer only, what he wants actually. Okay, this is the tool microwind. Actually this is based on CMOS layout and simulation tool, and it have a support for deep submicron technology up to 22 nanometer technology. We are now in 45 nanometer era, and it have support up to 22 nanometer technology, and it have support for silicon on insulated technology, and these are the various modules. I will explain this one later on when we will take that software: Nano Lambda, Virtuoso Fab, MemSim, Protham and ProTutor. These are the two books from TMH publication: Basic CMOS Cell Design and Advanced CMOS Cell Design. Even I have this one here right now. This will cover like the advanced topic like processor designing. I will tell the these two are the developer of this software, Itane Sikard and Sonia Bendre, and it will cover like your embedded memory and like simple processor, your radio circuit and like converter sensors, and FPGA designing, and all the related issue to silicon on insulated technology, and like a lot of things, lot of advanced things, and this is just for basic one. You can take out this like purchase from market also. Even someone is interested, he can write down this ISBN number. Now the question arising that why we are adapting the fast, like day by day our requirement is so high. Why? Because that is possible now. EDA tools, we have that EDA tools, and definitely we want more features. Even like आपका mobile है, you want more features day by day. Every day company का कोई ना कोई features आते रहता है. So definitely we are adapting this latest technology. And about the tool, these are the two things which we have to focus on. Like it should be ease of learning, like it should be easy, and more focus on design. like there are a lot of tools in market. So it is very difficult to decide which tool to purchase, which to not purchase. And the thing is that I think it should be like concentrate on design only, not tool. Tool should be at least simple to use. So basically the problem होता for the student like उनके एक सेमेस्टर में उनको lot of practicals are there, so they can't learn that tool properly, और वो उसको like properly they can't use that one. So definitely जब उस tool का उन्होंने proper utilization नहीं किया, they can't go for like proper project, they can't concentrate on that. So definitely we have to choose that kind of software which have concentrate on design only, not like tool. This is my email ID, you can forward an email to me, and this is our company site ni2designs.com. All the product information related to our company is available here, and even like lot of educational material like PDF related to your digital circuitry, your like CMOS technology and so on is available there. There is some formality, you just fill that form and just you can download that, and even we have demo version of all the software for that, you can even download that one also for even microwind also or for others one whatever.